Okay, so you want to get right to the heart of it. You're here because you really want to understand the next big thing, and today we're diving deep into something that's already pretty incredible.
Yeah, we're talking about large language models, LLMs, those AI systems that are already doing some pretty mind-blowing stuff.
Exactly. But we're not stopping there. We want to know how to make these LLMs even better.
Yeah.
How do we push them to the next level?
And the research you've gathered here points to a really interesting approach using what are called multi-agent systems.
Multi-agent systems.
Yeah,
So instead of having one giant, all-powerful AI, we're talking about a whole team of AI agents working together.
precisely. It's about moving beyond that single superbrain idea and exploring what happens when you have a bunch of specialized AI minds collaborating.
I see. So today our mission is to figure out why this approach of using multiple AI agents, each maybe powered by an LLM and with its own special skills, can actually be more effective than just relying on one massive LLM.
Exactly. And it's a question that resonates in a lot of fields. Even in my early work with NLP and gesture recognition, we found that breaking down complex tasks into smaller, more focused modules often led to much better results.
Interesting. So it's kind of like looking at how things work in other areas and bringing those ideas into the world of LLMs.
Yeah, that's a great way to put it. And this idea of distributed intelligence is really at the heart of multi-agent systems.
Distributed intelligence.
Yeah.
Okay, so what exactly does that mean in this context?
Well, for a long time, people thought that to model complex systems, you needed one massive complex model, right? Like if you wanted to model something like the weather, you'd need this huge, intricate equation.
I see. So we're moving away from that idea.
Right. What engineers and researchers have discovered is that a network of simpler models, all interacting with each other, can actually be more effective at describing those complex systems than one giant model.
That's kind of counterintuitive, isn't it?
It might seem that way, but think about it this way. Even with hundreds of billions of parameters, which you can think of as like the knobs and dials that the model uses to learn a single LLM, can still run into limitations.
So it's like trying to get one person to be an expert in absolutely everything. It's just not realistic.
Exactly. And that's where distributed intelligence comes in. It's about having a team of specialists, each focused on a particular aspect of the problem.
So instead of one superbrain, we're talking about a network of smaller, more specialized brains working together.
Precisely. And a great example of this is something called swarm intelligence.
Swarm intelligence. Like
Right.
a swarm of bees.
Yeah, exactly. Or think about an ant colony. Each individual ant follows very simple rules guided by pheromone trails left by other ants.
But as a whole, the colony can achieve some pretty amazing things, right?
Exactly. Through that simple communication and decentralized decision-making, they can find the most efficient routes to food, build complex structures, and even defend their colony against threats.
So in this analogy, each ant is like an individual AI agent with a specific task, and the pheromone trails are their way of communicating and coordinating their efforts.
Precisely. And in a multi-agent system, you have a network of these agents, each potentially powered by an LLM, and they all have access to different tools tailored to their specific roles.
So it's not just about having a bunch of LLMs in the same room. It's about organizing them strategically, giving them clear roles and responsibilities so they can work together effectively.
Absolutely. And one of the big advantages of this modular approach is that you can refine and improve individual agents without having to overhaul the whole system.
Right. It's like you can have different teams working on different agents, and then they can all be integrated seamlessly.
Exactly. And the source even raises a really interesting question. Why bother building your own summarizer agent if a high-performing one already exists?
Makes sense. Why reinvent the wheel, right?
Right. So we can start thinking about this ecosystem of AI agents where we can leverage existing expertise and build on each other's work.
That's a really cool concept.
Uh,
Okay, so we've got a good grasp on distributed intelligence. Now let's move on to this idea of structured prompts.
right. So structured prompts are all about how we communicate effectively with these AI agents.
Because communication is key, right?
Absolutely. We know that AI models in general perform better when they're given structured data, and LLMs are no exception.
So even though they're great at understanding natural language, the way we phrase our requests can make a big difference.
Exactly. If you give someone a long, rambling set of instructions, they're probably going to get confused.
And it's the same with LLMs, right?
Exactly. A
Right.
single complex prompt with tons of context and instructions can be really hard for the LLM to parse.
So how do we make things clearer?
Well, one approach is to use what are called structured prompts.
Yeah, okay. And what exactly are those?
Basically, they're a way of creating more organized and modular prompts often using predefined templates with a consistent structure.
So instead of just throwing a bunch of text at the LLM, we're giving it a more structured set of instructions.
Right, and there are tools and libraries out there like Outlines and LMQL that can help us do this.
And these tools basically help us create prompts that are easier for both us and the LLM to understand.
Exactly. It takes a bit more effort upfront to design these structured prompts, but in the long run, it can lead to much better results.
So it's about bringing a sense of order to the potentially chaotic world of natural language instruction.
Exactly. And this structured approach becomes even more important when we're dealing with multiple AI agents.
Also,
Well, because in a multi-agent system, you need to make sure that each agent understands its role and its objectives and how it should interact with the other agents.
right, so you need clear communication between the agents.
Exactly. And structured prompts can help facilitate that.
Can you give us an example of how this might work in practice?
Sure. So, in a system like Crew AI, which is mentioned in the source, structured prompts are used to define the basic building blocks of the system.
What kind of building blocks?
Well, you have the tools, which are the specific actions that each agent can perform. Then you have the tasks, which are the specific goals that the agents are trying to achieve.
Okay.
And then you have the agents themselves. And for each agent, you define its role, its primary goal, and even its backstory.
Backstory. That's
Yeah.
interesting. So it's like each agent has its own little personality.
In a way, yeah.
But-
It gives each agent a specific context and helps guide its decision making.
And the source gives an example of how this works in Crew AI.
Yeah. They show how you can define an agent with parameters like role, goal, backstory, and even settings for things like whether the agent can delegate tasks to other agents.
So it's all very clearly defined and structured.
Exactly. And that's important because it helps to ensure that the agents can collaborate effectively.
Right. Clear roles, clear instructions. That's essential for any team, whether it's humans or AI agents.
Bicycling. Okay, so we've talked about distributed intelligence and structured prompts.
What's the third key factor that can help us improve LLM performance?
The third factor is enhanced context.
Okay, so what does that mean?
Well, one of the limitations of LLMs is that their knowledge is basically frozen in time at the point when they were last trained.
Right. They don't have access to the latest information or to information that wasn't included in their training data.
Exactly. And that can be a problem if you need the LLM to provide up-to-date information or to reason about something that's outside its knowledge base.
So how do we address this?
Well, one approach is to use something called retrieval augmented generation, or RAG.
RAG. What's that?
Basically, RAG allows us to fetch relevant information from external sources and then add that information to the prompt that's given to the LLM.
So it's like giving the LLM access to a whole library of information.
Exactly, and it can be incredibly effective. The source even mentions that a smaller LLM equipped with RAG can sometimes outperform a much larger LLM that doesn't have RAG.
Wow. So having access to the right information at the right time can make a huge difference.
Absolutely. And while RAG is great for single LLMs, multi-agent systems can actually take this idea of enhanced context even further. Well, because in a multi-agent system, the agents are constantly interacting with each other and sharing information, they can actually build up a kind of collective memory.
So the system as a whole learns and retains information over time.
Precisely. And this memory allows the agents to draw on past experiences and insights when they're tackling new problems.
That's amazing. So it's like the entire system is constantly getting smarter.
Exactly. And the source mentions that there are different types of memory that can be implemented in these systems, like short-term memory for immediate context, long-term memory for more general knowledge, and even entity memory for tracking specific objects or concepts.
It sounds like there's a lot of potential there to really enhance the context and the capabilities of these multi-agent systems.
There definitely is. And again, we see a practical example of this in Crew AI, where you can simply set a memory, true parameter to enable memory for the whole system.
That's pretty cool.
Yep.
Okay, so let's recap. We've talked about three main reasons why multi-agent systems are so promising for improving LLM performance.
Right. We have distributed intelligence, where a team of specialized agents can be more effective than a single large model. We have structured prompts, which help ensure clear communication and collaboration between the agents. And we have enhanced context through techniques like RAG and the development of collective memory within the system.
And it's this combination of factors that really seems to be unlocking a whole new level of potential for LLMs.
Absolutely. We're moving beyond the idea of one giant AI brain and embracing the power of collaboration, specialization, and continuous learning.
And it's exciting to think about all the different ways that this approach could be applied in the future.
Yeah. The source ends with a very thought-provoking question. It asks what other methodologies we can borrow from different fields to further enhance LLM outputs.
So it's an invitation to think outside the box and to look for inspiration in unexpected places.
Exactly. Maybe we can learn from how human teams collaborate or from how different parts of the brain work together.
The possibilities are really endless, and that's what makes this such a fascinating area of research.
It definitely is. Thanks for taking this deep dive with me today.
My pleasure.
It's been great.
Until next time.
See you then.
Bye.